Assalamu alaikum. How are you all? Welcome back to my videos. And today I'm going to show you a 2-bit comparator circuit. I'm going to demonstrate that how does a 2-bit comparator circuit works. So to explain its working, I have made a PDF over here. And first I will explain all these steps in the PDF through some theoretical truth tables and the theoretical diagrams, and then we will be switching to the Proteus to check its simulation. So let's just start. So here is a 2-bit comparator circuit. So our 2-bit comparator circuit, we have basically four inputs. Let the first input be A, the second input be B, and the third input be C, and the fourth input be D. And For these three, for these four inputs, there are three outputs. So those four outputs can be n1 is equal to n2, n1 can be less than n2, and n3 should be greater than n2. So we have basically two bit numbers, so those are basically n1 and n2. So I have made a truth table over here to explain the working of the 2-bit comparator circuit. So for a 2-bit comparator circuit, the truth table can be drawn in this way. uh, if the logic A, logic B, logic C, and logic D is at zero state, then our three LEDs can work in the can glow. So first LED can glow, the second LED cannot glow, and the third LED can also not glow. I'm sorry. And in this way, this truth table whole just works. So um, I will demonstrate this truth table in the further Proteus simulation. So for the first condition, that is f1 is equal to n1 is equal to n2, I have made a Karnaugh map over here. So this is the Karnaugh map, and this is the basically equation, and this is the circuit which shows that n1 is equal to n2, and for n1 should be less than n2. I have made another k map over here, and you guys can see this k map. And for the that condition, the circuit is the governing equation is here, and the circuit is drawn over here. So we can implement this circuit in the Proteus. And for the third equation, the k map is drawn in this way, and the logic diagram is to be drawn in this way. uh, as now I have explained all those steps which are involved in a 2-bit comparator. So now I will be switching to the Proteus simulation to show you that how does a 2-bit comparator circuit actually works. So for this, I have made a 2-bit comparator circuit over here. So you guys can check. This part of the circuit is basically n1 is equal to n2. I have made the logic diagram of this circuit, and now I have implemented it in the Proteus. And for n1 should be less than is equal to n2, I have made the logic diagram over here, and for n1 is greater than n2, this logic diagram is shown in this figure, so you guys can see. And now to check either it's simulating in a proper way or not, we will compare it with our theoretical results. So firstly, the truth table says um, logic A at 0, logic B at 0, logic C at 0, and logic D at 0. For all these logics at 0 state, where we will simulate this circuit, and we are simulating this circuit. And when all these logics are low, we can clearly see that only n1 is equal to n2, because the LED which is put in over here, and this LED starts glowing, and according to the truth table, we can clearly see that when all these four logics are at zero state, the logic 1 will give us a 1 output, and logic 2 and logic 3 will give us 0 outputs. So we can counter check this thing with this Proteus result. And we can check any other type of the any other part of the truth table. So let's just yeah, consider this second row, that is 0 0 0 and 1. So first three logics at 0 state, and the final logic at 1 state. So let's change the logic. So for if we change switch the logic at the logic 4 at 1 and other three logics at 0, we can see that the second output is giving us a maximum output, that is n1 is less than n2, and according to the truth table we can see that for this our second led will glow, that is 0 1 and 0. And in this diagram we can see that 0 1 and 0, and by this we can clearly demonstrate that the our circuit is working in a correct manner. And the truth table is also being verified by this diagram. And by this we can see that as far as the construction of this circuit is uh, concerned, uh, so first, to explain that, I have first made the logic diagrams over here. You can see this and this, and we have implemented this in the Proteus. After implementing that, we have counter checked our truth table results with our simulated part. So you can see that our circuit is working perfectly. So by this this video ends. Thank you so much for watching the video, and kindly do subscribe my channel. And may God bless you. Allah Hafiz.